Programming isn't just about making computers do things, it's about communicating with other humans through code. As systems grow, teams expand, and requirements evolve, the clarity and maintainability of your code matter far more than the initial cleverness of your implementation. Today, we're diving into something every developer feels, but not everyone can clearly explain why naming, readability, and simplicity are so critical in programming. This topic comes from a blog post by Alvin Jaime featured on the AlgoSync community. You can check out the full article by clicking the link in the description below. All right, let's get into it. What is cognitive load theory? Cognitive load theory is a framework from educational psychology developed by John Sweller. It suggests that the human brain has a limited amount of working memory available at any given time, and the way we design tasks, or in our case, code, should aim to reduce unnecessary mental effort. There are three types of cognitive load. 1. Intrinsic load, the inherent difficulty of the task. 2. Extraneous load, the unnecessary complexity in the way the task is presented. 3. Germane load, the effort required to construct schemas or mental models. In programming, we want to minimize extraneous load and manage intrinsic load so developers can focus on solving the actual problems, germane load, instead of deciphering convoluted code. Why naming matters. You've probably heard this joke before. There are only two hard things in computer science: cache invalidation and naming things. The names you give to variables, functions, and classes are the primary interface your code has with the reader. When a developer reads calculate versus calculate monthly interest, they engage a very different level of mental parsing. Poor naming creates an extraneous load, forcing developers to guess what something does, interrupting flow and increasing the chances of mistakes. Here's a tip. Be specific. User list is better than list one. Avoid noise words. Instead of data manager helper, just use data processor, if that's what it is. Follow conventions. Be consistent with casing, prefixes, suffixes, and pluralization across your code base. Why readability matters. Here's another classic quote for you. Programs must be written for people to read and only incidentally for machines to execute. That's from Harold Abelson. Studies show that developers spend 10 times more reading code than writing it. This means that the primary audience for your code is not the computer, it's the future human who has to understand and modify it. To make your code readable, use whitespace wisely, group related logic visually. Limit function size. Aim for short, focused functions, ideally under 20 to 30 lines. Comment why, not what. If the why isn't obvious, explain it. Don't just restate what the code already shows. Use meaningful structure. Break large files into logical modules or classes. Why simplicity matters. Let's talk about simplicity. Martin Fowler once said, "Any fool can write code that a computer can understand. Good programmers write code that humans can understand." And Donald Knuth gave us this gem. The real problem is that programmers have spent far too much time worrying about efficiency in the wrong places and at the wrong times. What they are both saying is this: don't try to be clever at the cost of clarity. Trying to outsmart the reader with a single-line regex hack or terse bitwise manipulation might save you a few keystrokes today, but it could cost hours of debugging down the road. Instead, focus on simplicity. Avoid deep nesting. Use early returns to simplify flow. Prefer composition over inheritance, especially in large OOP systems. Don't over-engineer. Use design patterns when they help, not just because they exist. Be boring. Simple, predictable code is easier to test and maintain. How to apply this in practice. Here are some concrete steps you can take to embrace these principles in your daily work. 1. Use code reviews for teaching. Use reviews to share reasoning behind naming choices and refactoring for readability. Encourage discussions around clarity, not just functionality. 2. Read code regularly. Study open source code bases, your team's older code, or even your past work. Notice what's easy to understand and what isn't. Reverse engineering your code after 6 months is a humbling and enlightening experience. 3. Embrace linters and formatters. Tools like Prettier, ESLint, Pylint, or Black enforce consistent formatting, freeing up mental energy for higher-level problems. 4. Refactor. Refactoring isn't a luxury, it's part of your job. If a function grows too large or confusing, break it down and make small, frequent improvements as part of your development process. If you enjoyed the content, don't forget to hit that subscribe button and check out the AlgoSync Discord linked below. It's your chance to connect with like-minded devs and maybe even become the next featured technical blogger in our community. Thanks for watching, and I'll see you in the next one.